Okay, this video is about generalized expression rule for AS. Okay, um, from our previous video, we know that for an AS, that's an expression rule. Okay, so let's see how can we get that expression rule. Okay, say if I give you an example like 2, 5, 8, and 11. Okay, so you know that this is an AS with common difference 3. Okay, so let's see how could we establish that um, general rule. Okay, so from 2 to 5 we know that you add 3, right? But from 2 to the 8 you add 2 3. So that means from first term to the third term, you need to add 2 common differences. Okay? So how about to 11? How many common differences have you add? Okay? So actually that would be 3 common difference. Alright? Okay? So that means from the first term to second term, you add 1 common difference. So here's the common difference. Okay? From the first to the third, you add 2 common difference. From the first to the fourth, you add 3 common difference. Okay? So in general, can we do that for any arithmetic sequence? Of course we can. So for any arithmetic sequence, the form would be like this. Okay. So if T1 is our first term in the in an arithmetic sequence, then how about our second term? So our second term would be T1 plus D, right? Plus 1 common difference. And 3, third term be T1 plus 2D, okay? And fourth term would be T1 plus 3D, okay? So if we come to nth term, so it should be T1 plus how many D? Okay, think about this. How many D? How many common difference? Okay, so for the third term, it's 2 common difference. For the fourth term, it's 3 common difference. Okay, so for nth term, it should be n minus 1, not n, but n minus 1 common difference. All right? So that's for our nth term. All right. Okay. So that's how we get that explicit rule to generally describe any AS. Okay. But how about a more generalized explicit rule? Okay. So let's see if we are not going from the first term to the nth term. How about if we goes from like second term to the third term? Okay, so we see that from the second term to the third term you add 1D, right? But from the second term to fourth term you add how many D? You add 2D, right? And for the from second term to nth term you don't need to add that many D, but you only need to add n minus 2D. Okay, so that means if we start from second term, not from the first term, our formula would become Tn equals T2 plus n minus 2D. Alright? Okay? So let's compare. If we start from right? If we start from T1, then Tn would be T1 plus n minus 1d, right? When you start from T2 is equals T2 plus n minus 2d, okay, etc. So how about when we goes to Tn, but we start from not second term but mth term, okay? Then should be m minus md, right? Okay, can you see the pattern? Alright, so it's a bit difficult to digest. I recommend you to pause the video now and take a few minutes to digest the information. Alright, okay. Okay, if you have understood the idea of generalized explicit rule, let's try some example here by using what we have just learned. Alright, so this is a familiar but complex example. Alright, for an AS, if the common difference is 7 and 10th term 63, you need to find 40th term. Alright, so what rule are you going to use? I'm going to try two different methods for you to compare. Okay, right, so first I'm going to use method 1. For method 1, we use our previous explicit rule. We use Tn equals T1 plus n minus 1d. Okay, we use this rule. Alright, okay, because we need to find 40th term, but we have d, but we don't have T1, so you can't find 40th term at the beginning. Okay, so you need to find T1. So how could we find T1? You need to use the information like the common difference is 7, the 10th term 63. So actually we know 10th term. Okay, so if n equals 10, the formula becomes this 10th term. Okay, T1 plus 10 minus 1d, right? So we put 10 into n. Alright, okay, but we know that d is 7, okay, and 10th term is 63, so you further substitute, that's 63 into T10, and T1, that's what we don't know, okay, 10 minus 1, and the common difference 7, okay. Okay, so that's 9 times 7, 63. Okay, so we got T1 equals 0. Okay, so after you get T1 equals 0, how could we find 40th term? Okay, so T40 equals T1 plus 40 minus 1 times d, right? Okay, right, T1 is, now you know that's 0, right? That's 39 times d, so d is 7. So that's 273. Okay, so that's method 1. So for method 1, you still need to use our previous explicit rule starting from T1. Okay, so how about we're going to try to use the generalized explicit rule. Okay, so we're going to use this rule and put here. Okay, so if we use this rule, the focus should be on n and m. Okay, so which term are you going to start? Okay, so you are going to find 40th term, but it's given, that's 10th term is given, right? Okay, so they give you the 10th term and you are going to find 40th term. Okay, so for this rule, okay, so this is method 2. Okay, you just write n equals 40 and m equals 10. Okay. 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 M minus M equal 40 minus what? 10. All right. Times D. All right. Okay. So that basically you're substituting N and M. All right. Okay. N is the 40. That's what you are going to find. M is 10 because that's given. Right. So you start from 10 to find 40. 40th term, all right? So it's no longer n minus 1, but n minus m, that's 40 minus 10. Do you see the difference, right? Okay, let me highlight to you, okay? Right, and it's 40 is here, right? Okay, so our next step would be like, okay, so if that's 40th term, what's the value of 40th term? Should be 2, so the 40th terms are we going to find, right? What's our 10th term? So 10th term is 63 and 40 minus 10 times 7. Okay. Alright, so we get the answer in just one step. Okay, just in one step. Okay, so when you compare our previous method, can you see that? Can you see the difference? Okay, for method 1, alright, you need to find the T1 first and use T1 to find T40 because your explicit rule is from T1. Okay, but for method 2, you can skip that T1. You don't need to find T1. You can start from 10th term. You can still find T40, right? Okay, so in just one step. So you see how it saves you a lot of time. Okay, doesn't it? Okay, so that's our first example. Let's do one more. This time we're given you a term which come much later. All right, and you need to find a term which appears much earlier. Okay, right. So let's see this example. Okay, for this example, you see that's 60th term is 45, and the common difference minus 3, and you are going to find third term. Okay, how could we find third term? Okay, so it's given 16, and you are going to find the third. Okay, it's a bit different from the last one, isn't it? Because the last one you are given 10th, and you are going to find 40th, right? Okay, but this time is 16th. Is 16 is given, but you're going to find the third. All right. Okay. But you can still use that formula, right? Okay. So solution. So this time I'm not going to use two methods. I'm going to use only the second method, the more generalized explicit rule for AS. All right. Okay. So let's use this one. Tn, alright, equals Tm plus m minus m and times D. Okay, so be careful what should be n, what should be m. Alright? Okay, remember that if you use this generalized formula, make sure that m must be greater than m. Alright? Okay, so even though we are going to find the third, okay, but since you are given the 16th, alright, so n should still be 16 because m must greater than m. Okay, so it will be the case, right? Alright. Okay, first we get this n and m correct. T16 is 45, T3 is what we're going to find. Okay, so you don't know yet. Alright, it's plus 13 minus 3. Alright, okay, that means 45 T3 minus 39. Okay, 45 plus 39 84. Okay. Okay. So can you see the difference between this example and our last one? Okay. So we use similar method, but last one, you are given an earlier term, 10th term, to find a term which appears much later in the sequence, which is 40th. But in this example, you are given the 16th term, which comes much later than the third term, and you are going to find the third term. So it's a bit different, but the idea would be essentially would be the same. All right. Okay. So let's see another one. Okay. So that's the third example. Okay. Again, please try to read the question and pause the video for a few minutes, and I would like you to try by yourself, and we compare our methods, right? Okay. Right. So in this question, you are given two terms, 12 terms and the 30th term, and you are going to find a common difference. Okay, let's do it. Solution A. How can we find the common difference? Still, we are going to apply the generalized explicit rule, right? So the Tn, or sorry, got it wrong, Tn plus n minus m times d. Remember, m must be greater than m, right? Okay, so Tn, m must be 30, m must be 12. Okay. Okay, so you are going to find a common difference. That means that d will be unknown this time. So it's 99, it's 12, oh sorry, it's 36 plus 18d. Okay. So you can solve it. I trust you. So I will just give you the answer. Okay, so d will be 3.5. Okay. I will check it again. Yeah, 3.5. All right. Okay. So how can we find 100th term? Okay. So again, if you are using the previous explicit rule, you have to use like this, right? T1 plus 100 minus 1d. But then, do we know T1? No, we don't know. All right. So we're not going to use this explicit rule. Instead, we are going to change it a little bit. Okay, we are going to find it by using which to start from which term. Of course, we can start from 12th term or 30. Okay, you start from 30, right? Okay, then remember here you should use m minus m. In this case, n's 100, m's 30, right? And how about d? Okay, right? Okay, T30 we already know is 36. Oh no, sorry, it's 99 plus 70 times d. Okay. Okay, so that's the answer, right? Okay, so for this video, remember that instead of use the previous explicit rule, we're going to use the more generalized explicit rule. All right? Okay, and when you apply the rule, remember to make sure, okay, you always put a term with a bigger which comes later in the sequence on the left hand side. Alright, for example, T40 must be on the left hand side, T10 must be on the right hand side. Okay, and you can solve this much complex question more easily. Alright, okay.